Good day, everyone, and Assalamu alaikum. On behalf of Global CIO Forum, an international group of artificial intelligence, I welcome all the attendees for today's virtual summit on data, future of everything. Before we start the virtual summit, let me quickly give you a very brief introduction about the Global CIO Forum, an international group of artificial intelligence. Global CIO Forum is a non-profit community of CIOs and IT leaders whose mission is to facilitate networking and to collaborate on issues faced by the CIOs and IT executives. Not just that, Global CIO Forum serves as an ambassador to the programs, providing a connection to the ongoing exchange of information and ideas. And one such instance of imparting knowledge is today's virtual summit in association with International Group of Artificial Intelligence, also referred to as IGOAI. The group focuses on adoption of artificial intelligence and futuristic technologies across various verticals where they can be used in the present and in the future as well to improve the overall process. And the moderator for today's event is Dr. Aisha Bushagar, who is the Executive Senior Manager responsible for data analytics at Bank of Bahrain and Kuwait. Dr. Aisha is also engaged in research activities on information assurance and cybersecurity, privacy of IoT devices, cryptocurrencies, and blockchain technologies, in addition to the latest trends of e-business technologies and fintech. Without any further delay, I invite Dr. Aisha to take it forward from here. Over to you, Dr. Aisha.
Thank you, Manali, for the introduction. Welcome, everyone, to the virtual summit of Data, Future of Everything. It is my honor to be moderating such a distinguished speakers from all around the world. As we all know, technology is evolving and changing really fast, but what is more important to note is that data science is what most of technology is revolving around. Big data used to be the next big thing of the future, which was a few years back, yet we already live in the future and big data is everywhere. With the world increasingly turning into a digital workspace, data science is definitely the future of everything. Before starting our speeches for today, I would like to take you through the agenda of the summit. Started at 12 p.m. today with an introductory. We will follow up with an opening speech by Her Excellency Fawzia bint Abdullah Zainal, and then a keynote speech by the conference chair, Dr. Jassim Haji, following up by the distinguished speakers, Dr. Ilham Suleimani, Victoria Khalifa bint Abdullah Khalifa, Professor Idoia Salazar, Dr. Eva Mary Muller, and Narata Nagendra, and finally Dr. Zahra Rashid Al-Rawahi. The opening speech by Her Excellency Fawzia bint Abdullah Zainal. Let us all listen to the video, please.
بسم الله الرحمن الرحيم. الصلاة والسلام على أشرف خلق الله سيدنا محمد وعلى آله وصحبه أجمعين. أصحاب المعالي والسعادة، السيدات والسادة، الحضور الكرام، السلام عليكم ورحمة الله وبركاته. يطيب لي أن أرحب بكم جميعا من خلال هذا المنبر الافتراضي الذي اضطرتنا إليه الظروف الراهنة جراء تفشي جائحة كورونا كوفيد-19، وحالت دون اللقاء المباشر للوقوف على الموضوع المهم لمؤتمركم الكريم، والمتعلق بمستقبل جمع البيانات لمقاربة الخطى والانفتاح على صناعة العصر الحديث الذي سيمثل نقطة ارتكاز للمساعي التنموية لكافة القطاعات. وإننا ننظر لأعمال مؤتمركم هذا وما سيحمله من أوراق بحثية وأطروحات علمية وتجارب فاعلة بأنها إضافة نوعية لمسار التطور التكنولوجي، وخطوة جديدة للارتقاء بمستوى تفعيل الذكاء الاصطناعي على المستوى المحلي والإقليمي والعالمي، وتعزيز التوجه الأممي في الاستفادة من علوم البيانات في ازدهار القطاعات الحيوية وإدارة المدن بالطرق المثلى التي تخدم الدول والشعوب. السيدات والسادة، إننا في مملكة البحرين جعلنا من التحول الرقمي والاستخدام الفاعل للذكاء الاصطناعي هدفاً وطنياً ذا أولوية، منطلقين في ذلك من الرؤى السامية لحضرة صاحب الجلالة الملك حمد بن عيسى آل خليفة عاهل البلاد المفدى حفظه الله ورعاه، والتوجيهات الكريمة من لدن جلالته بوضع خطة وطنية شاملة تؤمن الاستعداد الكامل للتعامل مع متطلبات الاقتصاد الرقمي بتبني وتوظيف تقنيات الذكاء الاصطناعي في القطاعات الإنتاجية والخدمية من خلال وضع الأنظمة اللازمة واستكمال البنى التقنية وتشجيع الاستثمارات النوعية لضمان الاستفادة القصوى من مردود ذلك على اقتصادنا الوطني. وعلى أرض الواقع تسارعت المساعي من كافة السلطات لترجمة التوجيهات الملكية السامية، وتضافرت من أجل وضع الخطط والاستراتيجيات المستجيبة لمتطلبات العصر، والعمل على إدخال النظم التقنية والذكاء الاصطناعي في كل النشاطات والمجالات، الأمر الذي مكن المملكة من التعامل المرن منذ بدء جائحة كورونا كوفيد-19 وإحراز السبق في مواصلة عمل القطاعات بأقل الأضرار، مستندة على كفاءات وطنية عملت ضمن فريق البحرين بقيادة صاحب السمو الملكي الأمير سلمان بن حمد آل خليفة ولي العهد رئيس مجلس الوزراء حفظه الله. وإن الاستجابة السريعة في السعي لإيجاد منظومة تقنية لمسار العمل الوطني قد أتى ثماره، سواء من خلال الحراك التشريعي المتصاعد لتطوير المنظومة القانونية وموائمتها مع أهداف التطور العلمي والتقني، أو عبر تجويد مخرجات العمل الحكومي من خلال النشاطات العامة والخدمات المقدمة للمجتمع، أو الاستفادة من التطور التكنولوجي في النظام القضائي ورقمنة إجراءات التقاضي بدءاً من رفع الدعاوى حتى إصدار الأحكام. سيداتي والسادة، لا شك أننا نسعى للاستفادة من دراساتكم الحصيفة وأطروحاتكم الثرية وعطاءاتكم العلمية المتقدمة لتعزيز موقع مملكة البحرين في خارطة التقدم العالمي بمجال التكنولوجيا. وما هذه المؤتمرات الوطنية المتكاثرة في مجال الذكاء الاصطناعي بمشاركة رواد العمل التكنولوجي على المستوى الإقليمي والدولي، وما تشكله من أهمية وضرورة إلا مساهمة في الاقتراب أكثر للأهداف المنشودة، ولأجل ذلك تتطلب أن نعمل معها لزيادة وتيرة العمل وإيجاد المبادرات الخلاقة لاستثمار الذكاء الاصطناعي، بما يعود بالنفع والخير للنهضة التنموية لوطننا العزيز ولكافة البلدان، وتعزيز الموارد الاقتصادية وإيجاد فرص عمل جديدة ونوعية. وأن الإرادة الوطنية الطموحة ومع الانفتاح على التجارب الدولية الرائدة بالشراكة مع خبراء صناعة الذكاء الاصطناعي والباحثين والأكاديميين المتخصصين ستسهم في تقديم نموذج بحريني متقدم وكتابة قصة نجاح يحتذى بها في الاستفادة من الأدوات الفاعلة والمؤثرة للذكاء الاصطناعي في كافة القطاعات، لا سيما قطاع الصحة الذي تمثل الثورة التقنية فيه نافذة أمل لمستقبل مشرق في إيجاد حياة صحية آمنة للأفراد والمجتمعات. ونحن في مجلس النواب قد اتخذنا بالفعل خطوات عدة بالتعاون مع بيوت الخبرة العالمية للاستثمار الأمثل للذكاء الاصطناعي والتحول الرقمي في مجال العمل البرلماني، وقد قدمنا من التشريعات في ذات السياق، وإننا منفتحون للتعامل الفاعل مع كافة الأطروحات التي تسهم في تعزيز دور مملكة البحرين كدولة مؤثرة في تنفيذ أهداف التنمية المستدامة في المجال العلمي وتوظيف التقنيات الحديثة للارتقاء بالمنجزات الوطنية. سيداتي والسادة، إننا إذ نتابع ما يقوم به أبناؤنا وبناتنا في المجال الأكاديمي ومن خلال الجامعات المحلية من دور متميز في توظيف قدراتهم وإمكانياتهم في مجال الذكاء الاصطناعي عبر استخدام البيانات والوصول إلى نتائج مبتكرة يجعلنا نؤكد على أهمية ما طرحناه من اقتراحات لإدراج علوم الذكاء الاصطناعي في العملية التعليمية وإنشاء صندوق لدعم البحث العلمي في البحرين، إذ أن المعرفة تمثل الركن الأساس لإنتاج جيل قادر على التعامل مع صناعة العصر الحديث، كما أن الاستثمار في الشباب هو الرهان الرابح باعتبارهم المحرك الحقيقي للتغيير المستقبلي. وأود التأكيد على أن الذكاء الاصطناعي لم ينفك عن الاستدلالات التي يقدمها الإنسان في كافة المجالات، ونحن على ثقة بالإنسان البحريني وإمكانياته في ظل التقدم التقني والتكنولوجي الهائل وقدرته على وضع وطنه في مقدمة الركب العالمي والأخذ بالمسيرة الوطنية في ظل القيادة الحكيمة لجلالة الملك المفدى حفظه الله ورعاه نحو مزيد من التقدم والريادة. ختاماً، أتقدم بوافر الشكر والتقدير للخبراء والمتخصصين والمتحدثين وللحضور الكريم ولكافة القائمين على تنظيم هذا المؤتمر المهم الذي تحدون الثقة بما سيخلص له من اقتراحات وتصورات ورؤى يمكن معها الانفتاح على أفكار ومبادرات جديدة، حيث نؤكد أن توصياتكم وملاحظاتكم ستكون محل بحث ودراسة وستحظى ببالغ الاهتمام من قبلنا بإذن الله. والسلام عليكم ورحمة الله وبركاته.
We would like to thank Her Excellency for her patronage for our summit today and for her encouraging speech. Next is the keynote speech by the conference chairman, Dr. Jassim Haji, which is the president of the Artificial Intelligence Group. Dr. Jassim Haji has management and executive experience in aviation, hospitality, technology, and telecommunications for over 30 years. He participated as a key speaker and chairman in over 200 technology conferences in the Middle East and Europe to cover latest technologies such as artificial intelligence, cloud computing, big data, cybersecurity, and digital transformation. He has so many publications in the same areas, and he has been instrumental in implementing several projects related to artificial intelligence, machine learning, chatbots in Arabic. Furthermore, he implemented the first regional aviation hybrid cloud computing in the Middle East, the first global big data sentiment analysis in Arabic. Dr. Haji has received his doctorate in business administration from the University of Northumbria at Newcastle, UK in 2010. He has completed his master's degree in management of information technology from the University of Sunderland in the UK as well. He started his career with Sprint Telecommunications in London before joining Gulf Air in 1985 as a network engineer, and then moved to Sabre, which is an American airline travel IT solutions company. He then moved to EDS as an executive director, and in 2008 in Gulf Air as the director of information technology division. Dr. Haji served in the board of directors of a leading hospitality and tourism technology provider in the Middle East, and on CETA Council representing the Middle East and North Africa. Let us all welcome Dr. Jassim Haji.
Thank you, Dr. Aisha, for the introduction. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, ladies and gentlemen. Again, I would like to thank Her Excellency for patronating this event, which is close to her heart, and she has received the delegation 2 days ago and conveyed her greetings and support to all the speakers and attendees. This also shows the commitment of Kingdom of Bahrain towards the innovation, a kingdom which is placing itself as the future of research and development in the Middle East, a hub for the innovation. We just had Sheikh Khalid bin Hamad Al-Khalifa's Innovation Award in Artificial Intelligence completed and awarded yesterday. And this is actually our 7th conference within the year. It shows our focus on items related to artificial intelligence. The previous ones were related to AI in specific areas, being in the judiciary or in various sectors. The next one will be in the sustainable energy, in sports, in banking, etc. And today, of course, we are focusing on data. I would not like to add anything or hijack the eagerly awaiting presentations from our keynote speakers, which are coming from different parts of the world, in addition to Dr. Aisha, which also accepted this invitation to moderate it for us. We have keynote speakers from Bahrain, Spain, Morocco, Germany, UAE, UK, and Sultanate of Oman. Of course, what you will notice is it is probably by coincidence, but also to prove a point that we have women in this key area of the technology, i.e. the data science, are all frustrating to flourish the technology to the next level. I was fortunate to coordinate with such a huge galaxy of speakers and accepted the invitation. I would like to just touch upon one other point that we also in Bahrain establishing an artificial intelligence regional conferences, but also a group of expertise which will strive towards improving the AI in GCC countries and coordinate with each other. Data is being one of them. So without further ado, I will pass back the stage to Dr. Aisha to introduce the next speakers. I wish you all the success and enjoyable conference. I will get back later at the end of the conference, and we will be here through the chats if anybody has questions or recommendations, or at the end of it to email the organizers. Thank you very much and good luck.
Thank you very much, Dr. Jassim, for your keynote speech today. Moving on to our next or first speaker, Dr. Ilham Slimani, which is a professor at Mohammed First University in Oujda, Morocco. Dr. Ilham earned her PhD from the National School of Computer Science and System Analysis in Rabat. She is currently a professor at the Department of Computer Science at Faculty of Sciences at the same university. Her research and publication interests include machine learning, data science, supply chain management, forecasting and classification, in addition to IT security. Professor Ilham is going to talk to us today about automated machine learning as the future of data science. I'll welcome Dr. Ilham Slimani. The floor is yours, Doctor.
Thank you, Dr. Aisha. Hello, everyone. Today I will be talking about, Hello, everyone. Thank you, Dr. Aisha, for the introduction. I would like, first of all, to thank all the organizing committee for having us today, for giving us the opportunity to be a part of such an event, the first international conference on data, the future of everything. So I will be talking about automated machine learning as the future of data science. So the outlines of my presentation are as follows. We initiate this presentation by an introduction where we highlight the importance of data as the future of everything, in a digital global trend. We will present next the fundamentals of machine learning, starting with basic concepts such as artificial intelligence, automation, machine learning, deep learning, and classification, regression, and so on. Afterwards, I will be talking about the how-to of building concretely a machine learning model, then followed by some applications of machine learning using, of course, data sets from Morocco, and in the context of forecasting in transportation systems and supply chain management systems, then finally a conclusion. So as already said by Dr. Aisha and Dr. Jassim, the world is changing faster than ever, and we're always creating data, more and more data. We're already in the future, and big data is everywhere. So terms like data science, big data, dark data, data mining, we're familiar with those terms today. We're talking about those terms in many areas such as finance, supply chain management, transportation, and the solution to have an advantage, a comparative advantage, is to leverage to use these data in order to maximize our profits and learn from previous experiences. To do so, we have to use, of course, artificial intelligence techniques such as training, deep learning, regression. So those are terms about artificial intelligence that we need to know, to be familiar with. So to begin with, let's start with a typical business problem. Where we suppose like we're in a bank, and we're in bank with 2 million, for example, 2 million customers, and this bank is thinking about introducing a new credit card. So to do so, the bank sellers have the sales team marketing are executing a campaign offering to 2,000 of their customers, and of course let's suppose that unfortunately only 2% of their customers sign up for this new card, and the rest of them, like 98%, they didn't want this new card, perhaps because they're familiar, or they're more comfortable with paying it cash, with going to the local supermarket, or for some other reason, we don't know. So of course, the question for the bank is, how can we target more people from the first group, the 2% group, in the next marketing campaign, in order to maximize the profit. So to do so, the answer is in the data. So typically it takes months to get a project like that off the ground and deploy a predictive targeting model, but it is more fast, and it's so much faster if you use artificial intelligence techniques, where data is stocked in databases, and the next marketing action is based on information from the last experience, from what we've already seen, we've already done. So the next campaign, our next campaign, would be based on historical data and details of customer record in databases of all their activities. So it is easy to separate those who will be interested in our new card or those who are not. So this is a way to say that data is everywhere, and we have to use data in order to have an advantage, a competitive advantage in business. So there are so many terms, as I already said, such as artificial intelligence, machine learning, deep learning, and those terms are frequently confused and confusing. To differentiate between those terms, so artificial intelligence, it enables computers to perform tasks normally and that requires normally artificial intelligence, human intelligence, by allowing to mimic human intelligence. Machine learning, on the other hand, it is a subfield of artificial intelligence, and it is used in statistical learning, for instance, and that enables machine learning. It enables machines to learn and improve from experience. We're talking about more thinking and not doing things. However, deep learning, it's also a subset and a subfield of machine learning, and it's defined as a multi-neural networks. We're talking about layers and multi-artificial neural networks containing a large number of parameters and layers, such as convolutional neural networks, recurrent neural networks, and of course, artificial intelligence has many applications in many subdomains, such as speech image recognition, computer vision, robotic, decision support system, and we're doing it for so many things, going from semantic web to knowledge representation and so on. So of course, machine learning is a subset and a subdomains of artificial intelligence. The next question is how or what is the difference between automation and machine learning? Of course, when we talk about machine learning, it's implicitly we're implicitly talking about automation. However, there is a difference when we're talking about automations. So we're talking about doing things and doing it faster, and of course, based on computer and robotic desktop automation or robotic process automation. It's more a process driven. However, when we talk about machine learning, we're increasing complexity, and we're more talking about thinking and improving our tasks, our daily tasks, with thinking and with thinking about it and doing it much more better like human, by mimicking human intelligence. So machine learning is more about thinking about things and more about analyzing things. The next thing that I will be talking about is why do we use machine learning? To do so, we have to compare between the traditional programming approach and the machine learning programming approach. Of course, when we talk about when we have a problem and we want to solve it in a traditional manner, we should write rules. We should do that manually, and so we have, after that, we have to evaluate the solution, the proposed solution, and analyze error. So if it works, we will launch the solution. If it doesn't work, we have to analyze more, and we have to change the rules already done. So in the traditional programming, which we should remember that in the traditional programming, data and program are inputs of our computer, and we have to have an output from data and program. However, when we talk about machine learning programming approach, it's more about computer. It's more about data and outputs. We put data and outputs as inputs to our computer to have the program. So here we're learning about from data, and we're training our model, our machine learning algorithm or model from data in order to have the best solution in our problem. We have to, of course, when we talk about machine learning, it is about automating tasks. It's about thinking about things, and it is faster than of course the traditional programming approach. However, there is another related thing that is called automated machine learning, and it's about machine learning. It gives machine learning tools to automate repetitive tasks by applying machine learning to machine learning itself. It is about automating machine learning tasks such as choosing the database, data preparation, and feature selection. The literature review shows that there are three main types of machine learning, namely supervised learning, unsupervised learning, and reinforcement learning. In the supervised learning, an algorithm is used to learn the mapping, the regression or classification model from inputs to outputs. And however, in the unsupervised learning, it is used to do when we have data is not labeled, and it is mostly performed as the parts of analysis data, and it is commonly used for clustering and dimensionality reduction. The third type of machine learning is the reinforcement learning. It can be explained as learning by continuously interaction with the environment. In this third type, we're using agents, and we're giving rewards if an agent is performing correctly, and punishments if he's not. The next part is how to build a machine learning model, concretely how to build a machine learning model. Of course, each machine learning problem is, when we talk about machine learning problem, we always start from data. Initial data set where we have to extract data, clean the data, prep the data in general. And in here we're talking about pre-processed data sets. Once we have a pre-processed data set, we already have the input variables and the output variables. Next, the data is, we should split the data into two groups. The first, in general, it's 20%, 80%. The 20% is used as the test set, and the 80% as a training set. Algorithm, at this point, we should choose the appropriate algorithm, naming SVM as the support vector machine. So it's artificial neural networks, regression, and others, so many others. We're talking about validating the model and training the model using cross-validation model or other. Then the predicted value, the Y value is expected. At this point, we have to evaluate, of course, the obtained model, and if it's a classification model, we're talking about diffusion matrix, accuracy, sensitivity, etc. And if you have a regression problem, it's more about the RMSE or MSE, the mean squared error, or okay, it depends, as I already said, on the problem. The next thing that we're talking about is what are the challenges when we are building a machine learning project. What are the challenges that we should face? And in short, since your main task is to select a learning algorithm and learn it from some data, the main things that can go wrong is bad data or bad algorithm. For data, for the training data, it could be an insufficient quantity. So machine learning takes a lot of data to work properly. Another problem is the non-representative data. In order to generate well, it is crucial that your training data be representative on the new cases. And we can talk about poor quality, data poor quality at this point. So if data contains lots of errors, lots of noises, for sure your training is going to be ruined. It's going to give you wrong results. And the fourth problem relating to data is irrelevant feeders. This is what we're talking in here. We're talking about feeder selections, and it's more about your system will be capable of learning and from data that contains enough relevant feeders and not too many irrelevant feeders. So another problem related to algorithm this time is underfitting. We're talking about underfitting or overfitting problem. So for a regression problem, for prediction or forecasting problem, it can be the symptoms are high training errors or training errors. It is too close to test error. And on the other hand, for the overfitting problem, it can be seen as a very low training error, or training error much lower than test error. This is how you can see in here. This is in an illustration of underfitting and overfitting for the regression and classification problems. So, of course, machine learning or artificial intelligence in general, or machine learning in particular, are used in so many areas, namely robopilot, cars driving, autonomous vehicles, so face and speech recognition, and so on. In this part, I will be talking about application of machine learning using, of course, real data in Morocco. This first case study, we have data provided by a recognized manufacturer manager in Morocco, and it is data related to the toll station of Bouzniqa. Bouzniqa is where 60% of national traffic in Morocco highways is recorded in Bouzniqa. Since this toll station, it connects the biggest cities in Morocco, namely Casablanca and Rabat. The figure on the right illustrates the evolution of hourly traffic per day from this toll station in the year 2017, and of course the results of this first study so in this study we compared the predictive results of statistical and the machine learning techniques. The results shows clearly that artificial neural network, and more precisely multi-layer perceptual structure, gives the best results in this case study. Another study that we've done is in supply chain management. Of course, supply chain management is a group of systems, manufacturers, suppliers, retailers, transporters. So the main goal of each member of the supply chain is to maximize the profit by minimizing, of course, the costs. In this study, we combined artificial neural networks techniques with game theory. We tried to model our supply chain as a game of two players, retailer and the supplier. At this point, of course, the question is whether it is benefit to cooperate or not. And when we're talking about cooperation, it's about information sharing, it's about data sharing, so sales information related to sales and commands. At this stage, we used artificial intelligence networks to forecast demands, and of course using historical data and historical information related to sales to forecast the future demand, and found the equilibrium of the game, whether it is benefit for a retailer and the suppliers to cooperate or not, to share information or not. The results of this study are in here. So the actual demand versus forecasted demand for the test set is illustrated at the figure on the right. So we clearly, the model, the machine learning model that we use gives us satisfying results, since the training error was 0.005, and for the training sets, and for the test set it was only 0.028. And at this study we compared the predictive performance of LSTM, CNN, and NLP as the deep learning algorithms, and as the conclusion. So of course we're living in a world where we are producing lots of data. We're talking about big data. The forecasting, some of the problems that we're facing are related to forecasting problem or classification problem. So deep learning, or in general, is the future of everything. So however, it's not fully developed, and this branch of data science is the closest that we have gotten so far when we talk about artificial intelligence. In other words, so we have to be able to differentiate between programming, machine learning, and automated machine learning, as programming is when we're talking about managing routine tasks and using computer to help us to do so. Machine learning, it allows computer to learn from other experience, from previous experience, and perform better. However, the automated machine learning that combines automation and machine learning concepts, it helps computer to learn how to optimize the outcome. It is basically, it offers machine learning experts tools to automate repetitive tasks by applying machine learning to machine learning itself. Yet, to improve business performances, there is a new challenge of data science in general. And here we're talking about dark data as the new challenge to enhance business performances. Dark data can be briefly defined as neglected information. It can be unmanaged, it can be unclassified or unknown. Why not? Some examples such as web log files for websites, audio or video files, so customers' emails or visit tracking data sets. And it is a research field that still needs to be explored using, of course, automated machine learning techniques. Thank you for your attention, and back to you, Dr. Aisha.
Thank you, Professor Ilham, for your fruitful presentation today morning. Let us move on to our next speaker for today. Our next speaker is Victoria Khalifa bint Abdullah Al Khalifa, who is the director of the e-learning center at the University of Bahrain. Victoria Al Khalifa is a leader of 2 teams of specialists and multimedia experts, and is playing an active role in managing the digital transformation process at the university throughout the COVID-19 pandemic. She is also an assistant professor with a master's degree in building conservation and urban regeneration, and holds a PhD in sustainable urbanism. Her research aspires to contribute to the understanding of smart, sustainable urbanism within the context of transformed cultures, urban islands, and urban archipelagos. She was part of a team that won the Golden Lion Award in the Venice Biennale in 2010, and she was awarded RIBA's President's Award for Research in 2012. Victoria Al Khalifa was also awarded the Emergent Scholar Award in 2018 and the Smart Urbanism Award in 2019. Under her leadership at the University of Bahrain, they won the Blackboard Catalyst Award for Leading Change in 2020. She is interested in the implementation of smart urban solutions to achieve sustainable urbanism, the dynamics of sustainability assessment tools, smart sustainable urbanism indicators, and the influence of visualization on the opinions and actions of decision makers. She has published a number of papers in journals and conferences proceedings. She has also obtained a number of professional certificates, including the ISM certificate in Sales and Marketing Management and the NAIRP Advanced Certificate in Commercial Real Estate Development. It is quite interesting to know that Dr. Al Khalifa founded the Smart Sustainable Urbanism Lab, SSU, and the Reality Lab at the University of Bahrain. She is currently the lead researcher in a number of research projects that investigates the use of artificial intelligence in built environments, visual discomfort in urban areas, sustainable urbanism, and smart sustainable real estate development. Let us all welcome Victoria bint Abdullah Al Khalifa.
Thank you very much, Dr. Aisha, for the lovely introduction. I'll just try and share my screen with you here today. Okay, could you confirm that you can see my screen? Okay, so today I'm delighted to talk to you about data science and analytics in relationship to smart sustainable cities. I am interested in this integration between IT and the technology and smartness of things with how to attain sustainable outcomes for our urban environments. And I usually start every presentation by saying that today, in today's world, we cannot really distinguish between what is smart and what is sustainable, because if we look into the definitions of both terms, they're very much interrelated and interconnected. I will start by defining smart sustainable cities to talk about what they are and why are they important, and what are the new redefinitions for them. I'll talk about big data analytics and their relationship to smart sustainable cities, how are they related and how can they help the achievement of smart sustainable communities. And as an example of smart sustainable cities, one of their applications is urban intelligence and the use of urban digital twins. So we're going to talk about urban intelligence fields, tools, and the benefits of it, and then what urban digital twins can do to help us attain smart sustainable communities. And then I'm going to wrap up with the future works and what we can do as a community to attain smart sustainable urbanism through implementing a digital twin for Bahrain. So smart sustainable urbanism or smart sustainable cities, and I'm often asked the question of what's the difference between urbanism and cities. Urbanism is the life in cities, and cities mainly when we're talking about the physical features of the city, the buildings, the streets, the infrastructure. And urbanism is when we're talking about the life and the systems that helps us work within those cities. So as you can see, smart sustainable urbanism or SSU, the two terms benefit from the multiple terms of sustainability. There's no one universal definition for what sustainability should be, and different communities adopt different understandings for what they think sustainable and smart should be for them as a society. The world have seen more integration between the two terms recently, and one cannot be smart today without being sustainable, and one cannot be sustainable without being smart. So it's very timely that we look at those terms together all at once. So smart sustainable cities is an integrated and holistic approach to urbanism, representing a strategic approach to achieving the long-term goals of urban sustainability with the support of technologies and their novel applications. But we've looked at this definition and we found out that it really, yes?
Sulfay?
Yes?
We cannot see slides.
Sorry?
We cannot see your slides.
Okay. It says that showing Microsoft PowerPoint. I'm not sure. Maybe I could. Maybe you could remove the.
Yes, we can see it now, Doctor. Thank you.
Okay. Okay. So, yeah, I was saying that we have looked at the definition of smart sustainable urbanism and realized that it really misses the non-human aspect of smart urbanism. Oh, so we redefined smart sustainable urbanism to be this. It is an urban locality functioning as a healthy system of systems, because when you're talking about sustainable smart urbanism or smart sustainable urbanism, you're talking about everything that happens within the city, which is a very complex procedure of things that are happening all at once. Thinking of this with sustainable and balanced practices of the economy, the social, the environmental, and the governance, most importantly, all of these activities happening all together to generate desired outcomes and futures for all humans and non-humans as well in the city. And that's what we wanted to bring back to this definition of smart sustainable urbanism, that life in the city is not only about the humans, and about us utilizing the transportation and the telecommunication and so on for our daily activities, but it's also to give an opportunity for the trees and the birds and the animals to move freely within our cities and be as part of it for our own biophilic feeling of the city. So now, what is the relationship between this and big data analytics, and how can it help in the attainment of smart, sustainable cities? Here we're talking about then the concept of urban intelligence and utilizing urban intelligence. Urban intelligence, when you hear the term, you don't think that it's much related to sustainability, but if we look into the definitions, an example of this is on the slides here. Urban intelligence entails the use of big data analytics and the underlying core-enabling technologies to address and overcome the problems and challenges facing cities in the context of sustainability. Therefore, it's very much important that we look at them all together. Now, there are many fields where urban intelligence could be of help and could aid sustainability in that sense. One of them is real estate. You can use data and create those processes to enable you to make faster and smart decisions. And assessment of the development of the land and of property. It can tell you which parts of your urban environment is more profitable in the next 2 years, 10 years, and so on. And then you can make decisions based on the data that you have. And it also could tell you which parts of your real estate landscape in a certain city is most likely to harm a specific part of the environment. Therefore, you take the precautions and procedures to for that not to happen. Urban design and planning, we've worked recently on the idea of planning not only at the horizontal level, but also at the vertical level, and looking at what those skyscrapers in downtown urban areas are doing to the sustainability of our environment, and how they're not really maximizing the potential and the economic profit that they could gain, because they're not utilizing the data in the correct manner that they should be to able to see things correctly. So urban design and planning is a field of urban intelligence that is looked at now, and the usage of data is much part of it nowadays. Also, we're talking about now, we're not only dependent on architects and urban planners to design our cities, but it is more now the computer designing the cities, and the architects and urban planners are becoming at the back end, feeding this information into the computer to make up this plan of that vacant land or regenerate that area that exists. Urban management is a field of urban intelligence that is very important as well. Algorithms have been used to examine cities for enhancement opportunities, which parts of the cities are not utilized as well, or which parts of the cities that are been over-utilized, and therefore there should be an intervention in that space to kind of reduce the pressure on that urban area. So urban management is a very important field as well. So in order for us to use data in all of those different sectors, we would have to use a certain technology in the city to bring us the data or the raw material, the information that we would need to make up decisions or plans or design accordingly. So sensing and surveillance is very important. Sensors are used in responsive cities, drones and satellites to oversee and collect data from the urban environment that could be used and in AI, machine learning and deep learning and so on, to bring up decisions for the decision makers to use in those three sectors that I have discussed earlier. Smart buildings and infrastructure, interactive architecture, the idea that now the built environment is not very much static, it moves with you. Also the idea that we not only now design in the physical sense, but also in the virtual sense, as I will be showing later on in the presentation. Building information modeling, or BIM technology, automation in design and construction, can assess by analyzing the evidence and collecting the data available in the physical world and paper-based world, like building permits and so on, to put it into artificial intelligence systems to make up decisions and say which plans of a building or which plans are not according to the local regulations and should therefore be changed without having to depend on the human aspect, which could cause errors, like inspectors that could go into the building and check. Land use and planning, complex adaptive spatial systems driven by land use and land cover change, as I've discussed earlier about this idea of horizontal and vertical air zoning and planning. Now, say that we have collected all of this raw material and information from all of the systems that I've mentioned. How can we use it to better inform the decisions of our cities? There comes the idea of the digital twins of cities, which emerged only in 2017. These digital twins are a digital representation of a physical assets, process, or system. Previously, what we used to do is that we did a physical, smaller model of the city where we can see effects of different buildings like shade and shadow and how they are affecting the surrounding environment, or if you would to put a vacant land and convert it into a park, how would it reflect or change the life in the neighborhood that it is in. Now, instead of doing that, we can create a digital twin, clone basically the city in the virtual world, where we can use simulations to try out things and try out scenarios and see, for example, if a fire happens in one area, how would it impact the environment and buildings surrounding it, and so on, without having to actually wait for the event to occur in real life scenarios to see this. So in order for us to have that digital twin of a city, we need an enormous amount of sensory information from the city that we can obtain using the tools that I have mentioned earlier. Bahrain, the SLRV are working on obtaining very accurate satellite imageries of Bahrain or different areas of Bahrain, up to 1 centimeter accuracy of information that can be put into a digital twin later on in Bahrain of Manama or of Muharraq or any of our areas to enable us to see things in that sense. So the technology was initially developed for the commercial sector, for construction and manufacturing, and then was used in a larger extent to see the cities and how they would behave in such an events. So as they have evolved, digital twins are increasingly being used as a tool by cities. As you can see from the quotation on the screen, they will definitely change the way cities are planned, operated, monitored, and managed because of the information that we are now obtaining. Specifically now after COVID-19, we have an enormous amount of information and we're more into digitizing our processes, which enables us to have that raw data to create that digital twin. So it is anticipated that by 2025, we will have up to 500 digital twins of cities worldwide, up from just a handful in 2019. We only have a few examples now, but more cities are becoming more aware of this, and they are more intense to have that. I'll just present two examples of digital twins. Shanghai, China have decided to clone Shanghai and to have a digital twin on it. So about 4,000 square kilometers of land have been covered and cloned on the virtual platform to try and have those different scenarios using the data that is obtained from different sensors and different satellite imageries from the city. I'll just show a small part of a video that you can also find on YouTube if you're interested in the longer version of the video.
This technology firm in Beijing has created a complete virtual clone of China's largest city, covering almost 4,000 square kilometers and built using information from satellites, drones, and sensors in the real Shanghai. The digital replica could soon have the power to simulate events in the city's future with astonishing accuracy. Powered by Unreal Engine's photorealistic graphics, covering in thousands of buildings and with the potential to impact millions of people, this is how China cloned Shanghai.
Another city that have used the digital twin technology is Dublin. The city of Dublin in Ireland is also working with Bentley Systems to develop a large-scale digital twin of the city. Let's just have a look at what they're doing. There's no sound in this video, It's just this is the background or how they're working with the digital twin. So as you can see, it's a 3D generated model of the city where you can put the images of the buildings from the clear satellite images that you have, and then the data comes from the information that you collect. And what Dublin did, which is very exciting, is also to get the public involved in that. As you can see in the lower right-hand side, there are the citizen suggestions, where the citizens can look at this digital twin online and then suggest things to change in their neighborhood or in their area accordingly. So very exciting technology that is based on the data that's going to completely change our cities and how we deal with them. Jamie Cudden, the Smart City Program Manager at the Dublin City Council who works on this project, have basically commented on the impact of the pandemic on also designing digital twins for cities and how now we have more data than ever to create our digital twins of the cities. So I think today is the time for all cities to go through this and have that. So all of these digital twin cases or models need to have the following 5 capabilities for them to work. They need to analysis is one of them. For example, it is a complex system of systems to provide valuable knowledge, and we should be able to analyze information inside of that digital twin. It should be secure because of the security of the data and the importance of the data that would be entered into it. It should be connected with the city systems to provide live data. As things change in the city, they should also be changing in the digital twin. It should be integrated with the stakeholders, as we saw in the Dublin example, and how the citizens are also involved, same as for the planners, the designers, the bankers, the investors. Everyone should have a say and should have to be able to visualize this as well. There are, however, some challenges in producing those digital twins. We generally in the world, we're lacking the regulations, the right regulations in place to be able to put them in place and develop them and then use them in the right way. Cybersecurity and privacy is a big issue worldwide, and same for digital twins. The ecosystem, we are lacking the local calibers, both in Bahrain and also internationally, and the willingness of the private public sector to join together to develop those digital twins. And finally, the data management or the availability and sharing of the data, and who owns that data that would be uploaded into those live streamings of what happens inside the city. So the goal of the community is to discuss all of these challenges and to find common grounds to resolve them. I'd like to leave you with this quote, which I always like to end my presentations with, because I think it tells us really what a smart, sustainable city is. It is a city where humans, trees, birds, and other animals can grow with all their glories, imperfections, freedoms, and creativity. They are not just cities of technology, but cities of love, life, beauty, dignity, freedom, and equity. And that's how we should see the technology and all of these ideas that we're trying to discuss in enabling us to have better built environments. Thank you very much. That was it for me. Please feel free to capture the screen if you'd like my contact information for future collaboration. Thank you very much. Back to you, Dr. Aisha.
Thank you so much, Dr. Faye, for such an interesting presentation with the new terminologies that we have been introduced to today morning. Moving on to our next speaker for today, and now we're going to look at the importance of ethics in data and AI. With us today is Professor Idoia Salazar, which is a co-founder and president of Observatory of Social and Ethical Impact of AI. She is principal investigator of the Social Impact of Artificial Intelligence and Robotics Research Group, which is focusing mainly on the need of a multicultural approach to ethics in AI. She is a specialist in ethics in artificial intelligence and a professor in international degrees at CEU San Pablo University. She is also an author and a co-author of a different number of books, like The Myth of the Algorithm, Tales and Truths of Artificial Intelligence, The Revolution of Robots, and How Artificial Intelligence and Robotics Affect Our Future. She is in the list of experts to assist the European Parliament's Artificial Intelligence Observatory, and she is a member of the board of directors of the Association of Arco Atlantico para la Seguridad in Toronto Digital, I hope that I pronounced it well, Professor Idiola, and she's a founding member of the Springer AI and Ethics Journal and a member of the Global AI Ethics Consortium. Let us all welcome Professor Idoia.
Thank you very much, Dr. Aisha, and thank you very much to this organization to invite me to this very interesting conference. And thank you for all of the attendants that are today here. Can you please tell me if you can see my screen? Yes? Okay. Okay, and really thank you very much to Dr. Jasmine for also for inviting me to this interesting conference, and also for the previous speaker who really led me a very easy way to keep going, talking about the importance of data nowadays, and not only the importance of data nowadays, but also the importance of the responsible use of this data. Nowadays, as all the other my previous speaker said, data is everything. We generate data in every step that we make every day. Just to give you some tips about this, I'm sure that sometimes it's necessary just to stop and realize how much data we generate in our daily routine. Even our body nowadays is translated into data. We have like sometimes some devices that can measure even our health and translate everything into data. Data really is everywhere. In a minute in the world, just to be conscious about that, you can see here some of the data, some in which the different data that we generate every day. In every email that we make, in every text message that we make, every Google search that we do, in every second we generate a lot of data. Here you can see another, just to be conscious of it, the amount of data we generate in every second in the world. Really every person in the world produces more than 1.5 megabytes of data every second, and every year will double the amount of data produced in the previous year. At the same time, the global population that has access to the internet really grows at the same proportion that they generate new data. What happened with all this data? Can we use what can we do with all this data? We know this, we are now conscious of the whole amount of data that we generate like every day, but what can we do with all that data? That is a great challenge for humanity. Really, throughout history, really humans had invented new technology in order to deal with the different things that we had to face during the evolution of humanity. Nowadays, as we are seeing, we have this big amount of data that we generate in our daily routine. So what can we do as humans? We produce, we develop, we invent new techniques in order to augment ourselves and start dealing and know how to deal with all this data and use this data to gain new advantages for humanity. Nowadays, we are developing some techniques like artificial intelligence techniques, and inside these artificial intelligence techniques, we are developing specific specific things in order to communicate with these artificial intelligence machines in order to gain more advantages for us as humans. For example, this natural language in order to communicate in the same way that I'm communicating with you by the voice. We are now in the era of the voice, and we are using for that the different bots, different, like for example, Alexa, like for example, Google Home, in order to communicate with machines for us to make it easy to communicate with these machines and extract benefit from this data. So what can we do nowadays with the processing all this data? So we can optimize a lot of processes. In businesses, it's been so useful to optimize these processes. We also can do it to make predictions, for example, to predict sales trends. We also can use it to find new customers. We can use it for increasing customer retention, improving customer services, better management of managing marketing efforts, as we can see, as we could see in previous the previous people that were talking about this, or for example, to track social media interaction. This is just some examples for that of that. But how can we do it? As we said previously, we use artificial intelligence techniques as a tool to manage all this data. But then, what is the problem really with this artificial intelligence technique? I am going to be talking about ethics, and when I am telling you that it's just could be seen just as a tool, as something, a new technique that we use just to manage the data that we have, the big data that we already have. Really, we have to think differently when talking this technique of artificial intelligence. Why? Because we have like so many producers that come from science fiction movies or science fiction literature that we have, every one of us has in our head when thinking of robots or artificial intelligence. This didn't happen to previous technologies that we invented as humanity. So really artificial intelligence techniques are not new. This came from like we started to talk about artificial intelligence in the 1950s, but it's nowadays when we have, as we see, this big amount of data, and we are able to develop this technique in order to use it in our different processes. But while we do this, we keep thinking about artificial intelligence as something that maybe could overcome humanity or something to compete with, like you can see in this slide. We can also talk about things not very related to the things just as I talked before of optimizing processes or of all these more realistic things. We also talk about robots' rights. We also talk about these robots taking our jobs. We also talk about robots or artificial intelligence taking over humanity. And it's time to change our minds. It is time to see these AI systems just a way to improve ourselves, just a way to augment ourselves in order to deal with the data and to try to forget some way all the producers that we have associated with science fiction. Really, artificial intelligence can be used for so many good things when using the data to improve our daily routine. For example, that you can see in these different news, it could be used for, solve the different investigations, like for example, DeepMind AI really did it great, like solving protein structures. And we are nowadays, they are using AI systems also to discover new antibiotics, or for example, to treat cancer, to give personalized treatments to many people related to cancer and other diseases. And also, artificial intelligence was a great help to fight against COVID. But you could see another news, for example, that are not that optimistic, and you could see like some of like this one. So, for example, the case in which Google was using an AI system, but supposedly unconsciously had a problem with that, and they were like having a problem with the algorithms and the way that these algorithms recognize some images. And for example, Amazon had another problem, discriminating women in their process, in the human sources process. And you can see like thousands and thousands of examples of this. And sometimes it's not a matter of that these companies want to do it consciously. Sometimes it's a matter of not knowing the real impact of this technology, not investigating the impact of this technology before applying these systems deploying these systems in their daily things that they have to do. So AI systems really can be used for good. It could be, I really think that it could be very useful, for example, when with autonomous cars. And I really believe that it could be like very good in, for example, in because humans maybe can commit some, also can go to sleep when they feel bad, or they maybe when they are driving a car, whatever. And an autonomous car normally do not have that problems, and maybe they don't drink alcohol, they don't get tired, and maybe could help us when driving. I really think that it could be very useful for us. But also we could use these autonomous systems in order to use it as an autonomous weapons, and this is not good. So let's think about the artificial intelligence peculiarities. We have these specific peculiarities that did not have these technologies and other technologies, previous technologies. One is the autonomy, and another one is the decision-making process. These AI systems are able to make decisions by themselves. So we see these AI systems are able to make decisions by themselves, like humans. So we like humans when we make decisions, normally we think we have our ethics. So we think about ethics of artificial intelligence, and I think it's wrong. I think we have to keep talking about ethics of humans. The data that we generate by which we feed these machines is still data of humans. That the bias of the machines, so the bias of the machines are the bias of humans also. We have, it's like a mirror in which we look ourselves and we see, okay, we shouldn't be just translate the bad things that we have as humans to machine. We have to keep thinking about the ethics of humans, and not humans, and not the problem of the machines. This is one important sentence that I wanted to show you, because I think it's one of the keys of our present. Not because we can do it, we should do it. This is one of the main things, because nowadays that we have to think about when we deal with this technology. Because nowadays artificial intelligence systems, and in the future will be even more, can do so many things. It could be able to make decisions by itself, but should we leave the machine to leave decisions by itself in some specific cases? This is one thing that we have to think about. So it is important to think about the perceptions, the making decisions, and another one, our perceptions of these decisions. And there is an important thing that we have to think about this. If we think about the good impact in society of the artificial intelligence, sure, it would be better for the improvement of any business. If we do not think about that, maybe we are going to have trouble with the impact of this technology in society, and maybe the society will not see with good eyes all this technology of artificial intelligence. If you sum this with all the producers that society in general have towards these technologies. So just because to prevent all of this, we have around the world have created like more than 1,000 code of ethics for artificial intelligence. But really we have, as I said previously, we have to keep thinking about the basis that we had throughout the history of humanity, and keep thinking about the ethics of the basis of the ethics of humans, not now to think about different ethics for machines. Why? Because we have to, and we shouldn't, just to tell you, we shouldn't keep thinking about a global and international code of ethics for artificial intelligence, because it's like really important to think about the multicultural differences that we all have. I mean, I'm sure I'm not the same, do not have the same approach to ethics that people in Arabia or people in Germany or people in Morocco and people in different places. And I don't want to be like that. I'm sure every one of us have a very good, rich cultural differences, and we shouldn't be looking for just one, but think about and really, I really think that our different points of view really enrich every culture, and is good. These are just some of the things, the different perceptions that maybe could every one of us has, and they are not. That doesn't mean that I'm better than another person who lives in another part of the world, and the things, they are just different approaches. So around in all of these in this 1,000 code of ethics for AI, they are like specific commons. They're really elements that we have in common. Some of them are this fairness, transparency, reliability, privacy and security, accountability and inclusiveness. And all of these another important element, which is the explainable AI. All the decisions of this AI system need to be explained. Needs to be we need to understand as humans how these AI systems have made these decisions. And just to start finishing with the conference, I really believe that we need to keep an eye and be very aware of this. It is important to educate to everyone's society, no matter the age, no matter the social condition. We really have to educate people in the really impact of this technology, of the use of their personal data, in order for them to change the perceptions of artificial intelligence, in order for them to keep aside all of the prejudices that they have of artificial intelligence. We have to increase the social responsibility through this education. We need to create a greater critical spirit on these people. We have to create through this education people free of prejudices, and we really need to give the people this education to create more consciousness of the use of their data. So that is the only way by which we are going to just keep aside all of these prejudices that the robots will take over humanity, or we are going to be substituted by humans, and really to create a society in which we see these AI systems as a help for humans, and create a really good global village. And please keep in mind also this sentence, which I consider that is important. The danger is not in the technology itself, but in the use that we make for it. So just for that, just to give a tip about this, the European Union has released one white paper, the European Commission, I'm sorry, saying some specific thing that is necessary in order to regulate this technology. Not regulate this technology, but they are saying that is that we should regulate just high-risk applications, not the technology itself, but just high-risk applications. How, for example, facial recognition and autonomous systems, and just in a specific very sensible sectors, like for example public administration, transportation, these kind of sectors that could be more sensible. And this is a very good way of maybe leaving the space to this technology to keep growing a lot, but also create a balance between the good between the promotion of this technology, and also to do it in a responsible way, which we consider is the right way to do it. Okay, just the last thing, please. It is very important to educate society, and to create consciousness in the different businesses in order to really to understand the good use of artificial intelligence, not as a technique, but as a good way of improving ourselves as humanity. And just to say the last thing, that data is not the future, data is the present, apart from the future. And please, it is very important to use it in a responsible way. Thank you very much. Go back to you, Aisha. Thank you.
Thank you so much, Professor. And I really liked what you said about not because we can do it, we should do it. Thank you so much for such brilliant quotations today. And we're going to move now to our next speaker, who is Dr. Eva Marie Muller-Stuhler. She's the Chief Data Scientist, Advanced Analytics and AI Practice Leader. Dr. Eva is IBM's Advanced Analytics and AI Practice Leader and Chief Scientist for the Middle East and Africa. She's responsible for leading large-scale data science and AI and transformations. With over 15 years of experience in data science and AI globally, she has impacted many different industries, including oil and gas, energy, healthcare, and financial sectors. She has pioneered highly successful solutions with governments and top-tier organizations alike. Dr. Eva is one of IBM's distinguished data science thought leaders and a member of the Academy of Technology. Her experience and passion for data science, AI, and innovation has made her a regular on the World Best Data Scientist rankings. Dr. Eva is a trusted advisor to the government on change management through AI on the advisory board of the various organizations focusing on AI ethics as well. The floor is yours, Dr. Eva. Thank you.
Thank you, Dr. Aisha, and thank you very much for inviting me for today. I would like to share my screen. 1 second. Okay, I hope you can see my screen now. Is it sharing?
Yes, doctor. Thank you.
Okay, perfect. Thank you. So yeah, thank you and welcome everybody. I would like to talk today about what data science and AI actually looks like often in practice, and why companies don't really see the results, because we had a lot of amazing talks today about how to do it right. But one thing that we actually see is in practice, we see different results. So let me talk about how to really scale it, how to get fully deployed AI-driven companies, and how to get from the idea to really delivering an impact. When we look at companies nowadays and ask them, okay, is AI, is data science, is that on your agenda? Nearly every single company says, yes, we are planning on becoming insight-driven. It is really important. We have the data, we want to leverage on the data, and we want to see how we can improve our performance. But then when you look at how many of them are actually succeeding, only 1/3 actually report success. In my experience, this number is actually even lower. The number of companies we speak to who are getting frustrated with their data science team, don't see the impact, don't see what they were hoping for, is close to 95–97%, if I'm honest. So let's look at the typical journey of our clients and the companies we see. And they all started off a few years ago and thinking we want to be completely data science and AI driven. They had great expectations. They wanted to be AI everywhere. They wanted to make better, faster, smarter decisions and save a lot of money. They got into the competition of my PhD is smarter than your PhD, and hired everyone they could find. Right out of university, bought data science and AI products, and then got into the cycle of really fast POCs, saying we develop fast, we fail fast, and so on. But then most of them suddenly hit a moment of truth and saying, hold on, we're spending so much money on people, on resources, on data cleaning, and so on. Are we really seeing an impact on our business, and how can we describe that business? And most of them hit what we would call the second window of saying, what we've been doing in the past had not worked, and how can we turn it around? How can we actually learn from our mistakes and go to where we are and being AI driven and really seeing an impact? And this is really what it's about. What were the mistakes done in the past, and how can we do it right? The biggest mistake we see is when people talk about data and AI, they only see data and AI. So they see data, they see platforms, they see tools, they see smart kids who can program. But actually, AI is far more. To become a data and AI-driven company, you really have to see that it's a complete turnaround of your operating model, of your strategy, of how to adopt it, and it has to be fully embedded in your organization. So the first thing we see, so we basically, what we saw with our clients, we broke down in 6 different pillars and categories and said, okay, these are the 6 pillars we have to be aware of. In every single one of them, we have lessons learned, and every single one of them plays an important role in being successful in AI. So the first one we see is strategy pillar. A lot of customers and clients of us were starting off and saying, okay, you know what, here's the data, do some experiments, do whatever you want. You wouldn't hire a single person in another department into your company and saying, do whatever you want. Marketing has a strategy, sales has a strategy, research has a strategy. For some reason, in data science and AI, we just thought, come up with smart ideas, but without a strategy. And that is not successful. So when we think about what data science could look like and we dream about it, we think about something like Formula One, a highly optimized, every single item is built for one purpose with one goal, and that is to become better than everyone else, to outperform the competition. That is what companies expect from doing data science, but then they go ahead without a strategy. And often it ends up something like this. They take bits and pieces, they hire someone from competition, they take some code from Kaggle, and they put it all together and wonder why they're not winning the race. So it is really, you have to understand what is your corporate purpose, why are you here for, and how can you use data and AI to make better, faster, and cheaper decisions? How can everything you do support your organization, increase your revenue, decrease your cost, and turn your overall corporate strategy into a digital strategy and in a data strategy that all support the same purpose. The next reason why companies struggle is because it's not really embedded in the organization fabric. So companies have to change their operating model when it comes to delivering data science in a project. The question is, do you have, for example, a center of excellence for data science? How do you come up with the ideas? How do you go from creating to execution to actually operating? Is your C-suite committed? Do you have access to the right resources? So, for example, when you're creating, is it led by the business? Does IT talk to the business, and is actually business interested in putting it forward? Do you have AI governance guidelines going through the organization, or is actually each team collecting data differently and is doing pretty much what they want? Unless you have a clear operating model that is defined and set up to be successful in AI, you will struggle on these pillars, and it will impact your performance. The third pillar that we see is the one where we often focused on and saying, okay, data science is about data, it's about tools, it's about technology. That is right, but it's not just about data, tools, and technology. In IBM, we say there is no artificial intelligence without infrastructure architecture. So yes, it is about technology, but it's about the right technology. You need to have the technology that allows you to scale, that allows you to go from POC to full deployment, and where you can actually run your models where your data is. Another big problem that we see is data quality. And in an ideal world, you would have something like what we see on the left-hand side. The data is organized, you know exactly where to find it, you can take it out of the shelf, you have access right controls, it's audited, it's reviewed. You can trust what is in there, you can have a look at it, and you can put it back, and the next person can use it as well. In reality, is actually worse than what we see on the right-hand side. It's not just a pile of books. Data has different meanings for different people in different departments. One of the most entertaining questions is to go to a bank and ask them what means an active customer. Every single person you ask will tell you a different definition of an active customer. Active customer could be somebody who has money on their bank account, somebody who has banked in the last couple of weeks, in the last year, and so on. That impacts your algorithms, that impacts your outcomes. I often like to compare data science and AI with cooking. So when I'm setting up to cook, I need the right ingredients. So if I'm making a birthday cake for my friend, if I only have cucumber in the fridge, I will not, no matter how good I am in cooking, I will not get a nice birthday cake. If I have eggs, if I have milk, but all of that is completely out of date, 50% of my ingredients are actually missing, I will not be able to get a nice birthday cake. So it's really make sure you have the right data, you have the right data quality, and you can trust what your data, what inputs are already. The fourth important pillar is how do we actually deploy? How can we make sure AI is trustworthy and fair, and how do we monitor it? A lot of companies don't even have MLOps procedures. We have data science scripts and data sources and plots and everything scattered all over the place. It is impossible to get insights out of an unstructured MLOps procedures. You have your data scientists have a very high churn. So if one of the data scientists is leaving, nobody is able to take the project over. So how do you engineer, how do you deploy, and how do you monitor? How do you minimize the time to deploy? How do you minimize the time to value? And how do you have, and it goes back to the other pillar, the right infrastructure that allows deployment. If you're working on freeware that is scattered all over the place, you have your data models locally, you will not be able to go and fully scale. Another thing that often happens is actually companies completely forget about deployment. They think about the business understanding, they do their analytical approach, they gather some data, and they build their POC. But then what? And the fact that once you have your POC, you have to put it into an MVP and then into deployment. You then have to evaluate it, you have to monitor it, you have to retrain it, you have to make sure you can trust what is the outcome. And depending on how your business changes, you're able to scale or you're flexible about it. That is something that often companies forget, and it actually is a very different skill set that you need for that than for a junior who builds a POC model. Very important is accountability and understanding what your models are saying. So if your AI models fail, how do you explain it? If you're in oil and gas and your drilling manager makes a decision, would you not want to know when he was last trained and how old his knowledge is? So if you give that job to an IT solution, an AI model data science solution, don't you want to know how good it actually is and how old the information is? So, and the answer that was often in the past, oh yeah, the model told me so, is not good enough anymore. If you are in the news for building models that are not ethical, that are not monitored, that are out of date, if you're a doctor who makes a decision based on data that is 20 years old, it will directly impact your reputation, it will directly impact your shareholder value, and saying, oh, but I had a model is not good enough. People will be held accountable for that. And so the whole operational model, from how do I build reusable assets, how do I build reusable data, how do I go from idea to full deployment, is very important, and how do I make sure I can monitor and explain and retrain my model. The fifth pillar that is very often forgotten is building a culture that embraces data and AI, change management. The smartest AI solutions doesn't help you if nobody uses in your company. If the management doesn't trust its outcome and is not adopting it, there is no point in having it built in the first place. People often ask, will AI actually replace managers? And our answer is no. We don't think AI will replace managers, but we do expect AI managers that use AI will replace the managers that don't use AI. So if you have something like Google Maps and you don't use it, and you're always 20 minutes late to every meeting because you got stuck in the wrong traffic jam, it will impact your job performance. If you don't have a spam filter and you read every single email not knowing if it's good or bad, it will impact your performance. A lot of data and AI solutions are about performance improvement. And so if you don't adapt it, if you schedule your retail personnel in a less efficient way, it will in the end impact your store performance, your manager's performance, and they will replace you with somebody who's actually leveraging on that. The last pillar that is very important is actually people and enablement. So what does your team actually look like? Does your team matches your corporate and your company and the purpose of your company, the maturity of where you are in developing AI? There's no point in having the smartest machine learning algorithm developer if you're actually still in a very early state of data collection. It also means not just data building the team and the upskilling and reskilling for your data science team, but everyone else in the company as well. So what does it mean for your C-suite? How much do they actually understand about how they can learn about data and AI, how they can leverage on that? We also often think that a data scientist is somebody, the one-man show of somebody really smart sitting in the IT department crunching numbers. That is the recipe for failure. What data science is about, it's about a team sport. It's about understanding the business. Companies and people were always looking for the one unicorn, the person that can do it all. But the truth is that you will not find that. It's like running a hospital. You don't have one person running everything in one hospital. So break down the job and basically break it down in different skills. So instead of having one unicorn, build a unicorn team. Have a data engineer or a feature engineer, somebody who gets the data in. Have a business expert who really is able to understand the business problem and translate that into a data science problem. Have project manager, optimization engineers, ML engineers, data communicator, data visualizationist. It is many different skills and many different people that make data science successful. And it's not one person that can do it all. So wrapping it all up, it is not just about the right algorithm. It's similar to cooking. It's not just about putting everything in the microwave and having the most strongest microwave ever. It's about different algorithms. It's about different skill sets. It's about understanding why you're doing data science. And only if you think about all the different pillars, you don't have to be a 10 out of 10 in every single pillar. Your strategy doesn't have to be to outperform Uber, but you do have to be aware that you need to have a strategy. You do need to be aware what it means for your operating model, for your data and platform operations, for your change management, and for your people and enablement. So every single one has an important impact, and every single one you have to consider in your journey and how to scale AI. The one-man show of coding, being smarter than everyone else, does not work, will not get you to success. But if you think about it, if you have a plan about it, if you monitor and you have a strategy, then I'm sure you'll be very successful. Thank you very much.
Thank you very much, Dr. Eva Mani, for taking us through the journey of AI and the pillars of successful AI-driven enterprises. It was really interesting. We will move now to our next speaker for today, Ms. Nagendra. But before introducing our last speaker, I would like to bring to your attention that we are going to have a Q&A session after Ms. Namrata. So I would like to ask all the presenters today to be available. Second is for our attendees, if you can kindly download the handouts that are available to you on the right-hand side of the panel. I believe this is all what I have to say for now. Right, so Ms. Namrata Nagendra is going to take us to neuroscience. She is currently a PhD candidate in consumer neuroscience at the Pinotsis Lab affiliated to MIT in Cambridge. She is also a principal strategy and transformation consultant focused on helping businesses combine behavioral psychology, neuroscience, and technology in product development, business development, and marketing. Ms. Namrata, the floor is yours.
Thank you so much for that introduction, and I would like to also thank all of the organizers for putting together this absolutely fantastic event. It has been it's been really good so far, and as you all know, I'm probably going to be the last speaker for the day as well. So I'll try and keep this as succinct as possible and as well, hopefully as interesting as possible as well. Now, one of the things that I'm going to be focusing on in my talk is going to be regarding neuroscience and big data. Now, one of the many interesting elements of data and neuroscience is the fact that neuroscience is actually a field that has existed for nearly 100 years. And whilst we're looking at neuroscience itself, one of the most interesting things is the fact that there's quite a lot of elements within neuroscience. Yeah, sorry. Yes?
Ms. Namrata? Yes, we cannot see your slide.
Oh, yeah, okay, just give me 1 second.
Yeah, we cannot.
Okay. Is that visible now?
Not yet.
Thank you.
We can see your desktop now. Yes, and now the presentation.
Fantastic, amazing. Let me just get that up. Okay, I'm just going to...
It disappeared again.
Okay, there we go. That should be visible now.
Thank you.
Fantastic, thank you very much. Great, so with regards to when you think about the world of neuroscience, neuroscience has actually been a field that has existed for nearly 100 years, and there's been quite a lot of research that's been done. Now, neuroscience refers to the study of the brain. And when we think about big data, one of the biggest questions that we have today is, what is big data? Big data refers to data sets with sizes beyond the ability of commonly used software tools to capture, curate, manage, and process data within a tolerable elapsed time. Big data is a set of techniques and technologies that require new forms of integration to uncover large hidden values from large data sets that are diverse, complex, and are of massive scale. Now, when you think about the brain and as human beings, one of the interesting things is that human beings are really, really complex organisms, and we work across different spatial scales. Now, what do different spatial scales mean? Different spatial scales mean we look at things like the body, we look at the brain itself, which is quite literally a 3-pound mass of jelly. And one of the interesting things about the brain is the brain is comprised of different regions, and we look at these different structures and how they interact with each other for us to be able to execute certain behaviors. So even when you do simple tasks such as talking, listening, learning, all of those tasks vary in complexity. And how do these different regions interact in order to sort of create these different behaviors? When you look into the deep depths of it, you also look at things like microcircuits, which are basically elements that, or processes that interact with each other in order for us to be able to manifest these different behaviors that exist. And these microcircuits as well, they need to also work in sync with different cellular structures and different connections or synapses, which are influenced by small, tiny proteins at almost a different complete level. One of the most interesting things is that all of these processes need to occur simultaneously. That is so much more complicated than the world's greatest computer or even the largest supercomputers that have been invented to date. Now, we're probably wondering, what is cognition, right? So when you look at things like development and aging, where you look at how people go from being babies all the way to growing old, there are different behaviors that sort of manifest over different periods of time. And these different behaviors result in different complexities. And these different complexities are basically the co-products or byproducts of various interactions that are currently happening over time. Cognition, or how we interact with the world, arises from this interaction between molecules, between cells and brain regions on time spans spanning around 18 orders of magnitude. So you're not just counting years, you're not just counting days, you're not just counting hours, but you're also counting minutes, seconds, milliseconds, microseconds, nanoseconds, and picoseconds at different levels. Now think about how much data is currently being collected, not just when you're executing a particular piece of behavior, but also when you are saying a particular sentence, or when you're processing a particular visual, just like this slide, or when you're trying to listen to a piece of information and process it at the same time. All of these different interactions also are resulting in different outputs, which eventually are being collected and processed by your brain, and also resulting in you being able to effectively and efficiently be able to learn a particular concept. Thinking about different regions of the brain, as well as different levels, as we talked about before, each of these has its own big data applications, because the amount of data that is collected from each and every stage or each and every layer of process is so incredibly large that what is interesting is that in the last 100 years of neuroscience, we still haven't been able to even scratch this surface. And with regards to being able to understand these different processes in the brain, different neuroscientists have created what are called imaging technologies. Now, imaging technologies basically identify different measures or ways in which we can understand or ascertain internal processes that are currently occurring within your brain. So say, for example, when a person is talking, which particular area is activated, which particular area or areas are being activated? How do you know, or how are you going to be able to measure whether a particular person is listening actively or not? Or alternatively, when you look at a particular item in front of you or an object, how is that object being processed? How is that particular item encoded? And then eventually you being able to recognize it all happening in real time. So imaging data is actually one of the ways in which neuroscientists collect different pieces of information in order to understand various processes and different functionalities within the human brain itself. Now, imaging data, there are a different wide variety of acquisition methodologies by which we can understand and acquire these different ways in which people interact with the world. There are also different ways in which we can measure it. And with each particular type of acquisition and measurement principle, you've also got certain limitations or artifacts. Now, artifacts are what are called noise. Now, as human beings, since there are multiple processes going on at the same time, how do you isolate which particular process is doing what, or which particular area is doing what? And in order to analyze that particular piece of information that you're trying to get, you have various analysis principles and you have different acquisition strategies for you to be able to collect the cleanest data possible, be able to process it in order to be able to extract and understand and get various insights from the same. Now, going into a couple of the imaging technologies that we've been looking at as neuroscientists over the years, there have been so many that have been developed for different purposes. So you've got structural MRIs, which basically take multiple images in order for you to be able to understand structures of a particular individual. So super helpful, especially when you're trying to understand things like differences, variances within different brain structures. Especially helpful for being able to diagnose diseases and being able to diagnose certain conditions early on. Now, what do structural MRIs give us that other imaging technologies don't? Structural MRIs are very, very specific in terms and with regards to being able to, one, provide us with only images of certain structures. We're not going to be able to understand whether a particular region is activated or not. So from a structural MRI, I'm probably going to just be able to understand what a particular person's brain looks like. Then you've got alternative technologies such as diffusion MRIs, which provide us with information about different data sort of networks within the brain, where you're able to understand what are the different connections that are currently being activated or how these different connections are arranged in order for you to get a much more better understanding of how these different networks work with each other. Then you've got functional magnetic resonance imaging. And now what functional magnetic resonance imaging does is it actually tells you which particular area of your brain is being activated during a particular task. So say, for example, if one of you in the audience or if any one of the panelists were in an fMRI machine, one of the most interesting things that we would be able to do as neuroscientists would be, I'd be able to put, say, a slide in front of you and be able to understand which areas of your brain are currently processing that particular slide. Is it your visual system? Is it your learning system? Is it your recognition system? Which particular system is involved? And the way that it does this is by taking multiple photographs of the brain, as well as understanding differences in oxygen levels. And this is all happening whilst a particular participant is in a scanner. Now think about it, if we have to take around 3,000 photographs over a certain period of time for one visual stimuli, think about how much data that would equate to. if you're running a particular experiment, or if you're looking at how different people interact, or basically look at different things, that is such a large amount of data that is collected in such a short span of time for just one experiment. And over the years with neuroscience, we have collected the hundreds of years worth of information that currently needs to be all collated together. You've also got other methodologies such as CT scans, and these are all images. And the reason why we're stressing on images and being able to understand that images are all currently being collected is because, one, different images require really large processing power. So you need to have really high powered computers in order to process that data. And once that data is sort of processed, being able to extract and understand and being able to identify variances and compare those variances over time is such a large task that is undertaken. And as neuroscientists, we actually deal and almost wrestle with this data and wrangle this data on quite a day-to-day basis in order for us to be able to understand how and be able to uncover the mysteries of the brain. You've also got technologies such as EEG, which basically look at activation patterns or wave patterns. And it's very, very similar to if you were looking at how electrical currents were created. Now, your brain is basically, as I mentioned, a 3-pound mass of jelly, and it's got all of these various connections and circuits within it that are interacting with each other. And when all of these circuits interact with each other, they all release electrical currents or electrical charges for us to be able to understand which particular neuron is firing at that point in time, which particular area is being activated, or what is the type of activation, how intense is that activation. Now, differences between a technology such as EEG and a technology such as an fMRI is that fMRI is able to give you only spatial resolution, where you get images and you get a sort of sum total of what area is being activated. With EEG, on the other hand, you get the length of activation, as well as how long it takes for something to be activated, as well as how intense that particular activation is. Intensity as well as temporal resolution is what you get from almost wave data. Now imagine being a participant that is interacting with, say, a visual stimulus for over 15 minutes. That generates nearly 4.5 to 6 gigabytes of data, which eventually needs to go through the process of, as any data set would, cleaning, processing, being able to extract and understand and analyze, and being able to put all of those insights and analysis into understanding different experimental protocols. You've also got slightly more advanced technologies nowadays, which basically help you understand how the different connections in the brain sort of function by inserting different probes and different inks in order for us to be able to get almost a pictorial representation of how many connections are there. Now that on the screen right now is what it would look like if you had a picture of all of the different connections in your brain hemispherically represented. Now, one of the greatest things about being in neuroscience and interacting with neuroimaging technology is, one, any kind of advancement. It's taken us years for us to get from very, very simplistic forms such as EEG to being able to take multiple photographs of the brain with fMRI or with MRIs. And as advances in neuroimaging technology sort of go ahead, one of the most interesting things is the fact that neuroscience data also gets really, really large. And one of the things with neuroscience data becoming extremely large is that it results in this really interesting circle where you're able to, one, advance neuroimaging technology because of the insights that you've previously collected. You're able to gather more data. You're able to create more enhanced neuroscience questions. You're able to work with more participants at a particular point in time. You're able to execute particular experiments across the world and create all standardized practices in order for us to be able to do that. And with being able to gather more data, asking more better questions, and being able to scan more individuals, it results in, again, a lot more data being collected, which feeds the need for more computation and data storage, resulting again in a desire to collect more data, eventually turning into this circle that eventually leads to such a large amount of data being processed. Well, you're probably wondering, like, what is the point of, being able to understand what exactly the brain does and how exactly the brain functions? Now, the reason why neuroscientists wrangle such large amounts of data is because they're trying to replicate experiments. They want to ask new questions. They want to be able to teach, to search for new types of information and eventually be able to publish that. And the reason why we do this is because we're looking to visualize each area of the brain, which till date still hasn't been done. There's so many things about the brain that we are still discovering. There's still so much left to analyze, and there's still so much that we still need to understand about functionalities and about circuits and about processes and how all of these react and interact with each other at the same time. If you think about, say, for example, an EV or an electronic vehicle or an autonomous vehicle, how do self-driving cars drive themselves? They essentially process the road in front of them, and they understand and they are able to detect different objects that come in between, and they've been trained over time to understand how these particular objects vary in size. Now, one of the biggest problems that currently exists within autonomous vehicle creation is the fact that most autonomous vehicles are unable to distinguish between shadows, because shadows, according to us as human beings, is a result of us understanding that a shadow is a concept. It is basically light falling on a particular object that results in a shadow being created. Now, it's simple for us to be able to run a data set and be able to teach a particular computer how to distinguish between items or objects. However, the challenge lies in us being able to explain conceptual information such as shadows, such as reflections, to a computer. The reason being, at the moment, we still don't understand how we as humans are able to understand these different concepts. How do we take a concept such as a shadow and how are we able to internalize it, learn it, and be able to understand the next time we look at something that that's a shadow? The other interesting elements that come into play involve us understanding, for example, being able to recognize different features of a particular item. How do we know how to pick up a mug, and why is it that the way we pick up a mug is so different than the way we pick up a phone? And that is one of the most interesting things about being able to understand how the brain does different things, because when you're able to visualize, when you are able to analyze, when you are able to model different interactions, you're able to simulate it, you're able to understand it, and eventually be able to feed that in order to create much more better technologies, much more technologies that are hopefully much more ethical, or hopefully are able to understand a lot more in terms of being able to recognize items, being able to differentiate between items, and eventually become more smart. The interesting thing is it has taken us 10 years for us to be able to reconstruct a neural network for a worm that has only 302 connections within the brain. 302 connections took 10 years, as well as a lot of computing power, in order for us to be now able to understand how that particular organism's brain functions, as well as how that organism's brain results in different behaviors being created. Now imagine if it took us 10 years for just 302 neurons, how many years is it going to take us for a human brain which has nearly 85 billion connections? That's going to be quite a lot. And one of the biggest challenges at the moment that we have is that as technology advances, neuroscience also advances at almost the same pace, potentially even faster. And for us to be able to simulate and be able to understand how the entire human brain works will require nearly a zettabyte of data. an amount of data that is approaching almost all of the information recorded globally today. And that is one of the most amazing things about being able to work in a field such as neuroscience, because once you do understand and you're able to uncover really small elements of how a particular brain works, it becomes almost imperative for us to be able to feed that into creating much more better technologies. And it becomes almost imperative that the foundations of artificial intelligence lie in neuroscience. The future of neuroscience and big data is one not only to understand brain function, which is for us to be able to wrangle all of that data, be able to process it, be able to put it all together to good use. It becomes essential for us to be able to do that, because for us to be able to understand different functions of how a particular brain works will eventually be able to provide us with insights to create machines that can hopefully perform the same functions, especially relevant within places such as working with paraplegics or quadriplegics, for example. How do we know how a brain, or how our brain is able to understand how to pick up a particular object, how to interact with a particular object? How do our muscles work? How do our muscles work in sync with the brain? What happens, for example, if one of your fingers is taken off? How does your brain compensate? Because there's so many different compensatory measures and so many parallel processes that go on at the same time that till date we're still unable to unearth the exact functionalities of how this particular organ functions. The second bit is for us to be looking at modeling disease characteristics. There are so many different neurodegenerative diseases, from schizophrenia to Alzheimer's, that are still, people are unable to explain how these different diseases manifest. How are we going to be able to understand how a particular disease manifests without us understanding different functionalities, without us understanding which is cause and which is effect, without us knowing which came first, whether it was structures or structural integrity within the brain that was sort of compromised for a disease to manifest, or whether it was an external factor. And the third being personalized medication. Eventually being able to, say, for example, take a scan of a particular individual and be able to understand what potential diseases they're able to, one, hope maybe in the future, possibly inherit, and creating different medications that are almost tailored to help that particular individual. Because one of the things that is super interesting is that whilst all of us might have very, very similar brain structures, all of us behave very, very differently. And for us to understand that holy trinity, it becomes almost impossible, where we've got how the brain, which works like a sponge, you've got consciousness, which helps us all be human, and you've also got elements such as personality. How does each and every person have different personality? There's no scale in the world that unfortunately can at this time help people understand how that would work. And then finally, you've got being able to model, being able to put all of these different brain processes and functions in a computational format for us to be able to utilize those insights in order to create smarter machines. And that is one of the most fascinating things about working within neuroscience, which is, it is an absolutely exciting field nonetheless. However, in order for us to be able to leverage this knowledge or this model of the world that we all have, and be able to project it forward in time, be able to evaluate things like future states, be able to help us understand different things. Humans are really, really good at doing a lot of things that we think are incredibly simple. For example, we all know how to drive a car, we all know how to use a laptop, we all know how to use a chair, or where we all know how to deal with unfamiliar situations. But imagine being able to put that into a network architecture, almost like a progressive network where it eventually learns just like human beings do from experiences, and be able to create machines that eventually are going to be within the same architecture of knowledge that we as human beings have. be able to model how we as human beings behave in order for us to be able to create these different machines and distill intelligence that we currently have into algorithms. And the root and the base of all of this lies within us understanding how we function as humans within society. Not only could it bolster a quest to develop artificial intelligence, a tool that we all hope will create new knowledge, will not only push forward scientific history, but it may also help us understand what is going on within our own heads. This could also shed a lot of light on the most enduring mysteries in neuroscience, such as the nature of creativity, dreams, and perhaps one day even consciousness. And with so much at stake, there is absolutely a need for us to be able to put all of these three things together, the data that is collected from neuroscience, as well as artificial intelligence, clubbed together in order to create a world that we can hopefully all be able to create a much more smarter world and a much more technologically driven world. And with that, I hand it back to the moderator. Thank you so much for your patient listening, and I hope that was slightly interesting.
Thank you so much. This was our last presentation for today, and it was a very interesting presentation with interesting facts and figures. We'll now move to the last part of the summit, which is the Q's and A's. If I would kindly ask our distinguished speakers for today to switch on their cameras and join me here in the panel. All right, thank you so much. Right, so like we all agreed today, data science is a large part of multiple fields, like you all explained today afternoon, and the demand of big data analytics and data science in the industry is actually increasing, and they need to do things faster and more efficient and in an automatic manner, which is sometimes even not possible by humans. From your point of view, do you think that the world is surviving or thriving data science? I'll give you the chance to comment on this. We'll start with Dr. Ilham Sliman. So you think we are barely surviving, or are we just thriving?
I think from my point of view and from my experience, I think we have to survive. It's not an option. We have to it's a tool that we have to manage it. We have to be able to maximize our profit, and we have to use data and artificial intelligence and so on, so we can have an easy life. We can automate our daily tasks. We have to survive. It's not an option. It's not a question. I think so.
Thank you, Dr. Ilham. Victoria Khalifa.
To be honest, I think we're barely surviving in that sense. If you will just put it in those two categories, I think we're barely. I think we have too many data in a very short time to be able to handle, to be honest. Talking about everyone altogether, I don't think yet we have the caliber to deal with all of this at the same time. And specifically, I'll be talking about the COVID-19 and the consequences of what happened and moving everyone online and having all of this data available of all of these processes that suddenly within a matter of a year all went online. So I think we have, you know, we sometimes bite more than we can chew in terms of data, but I do think that we are progressing, and as Professor Adham has mentioned, we have no other option but to deal with it and know how to deal with it. But I think we're surviving, if that's how to put it.
All right, thank you so much. What do you think from a neuroscience perspective, Namrata?
Well, absolutely. I do think, and I think as I do agree with my fellow panelists as well, that yes, at the moment, I don't think as a society yet we are completely equipped to process the amount of data that is being generated as efficiently and effectively as possible. And one of the major things that is currently going on right now is really looking at data disruption, not only from an industrial perspective, but also from a scientific perspective. And a major challenge that most businesses and organizations and society in general is undergoing is the essential digital transformation that is deciding how we deal and deluge with data, whether it is from an ethical perspective, whether it's from a processing perspective, or whether it's from a strategic perspective. I think we have a long way to go, and we're probably just getting started with that journey. Over to you, Dr. Aisha. Yeah.
Right, thank you so much, Namrata. And my next question is, actually, we all know that COVID-19 has changed the scenario of big data and AI-related development. It has created a kind of a disruption, and organizations nowadays have to change the priority for big data analytics and AI-related activities from long-term to short-term objectives. Now, beyond the COVID-19, we all agreed today that the professionals have to ride the augmentation wave. And this leads me to a question here from the attendees. The question says, how can big data with neuroscience bring a revolution in medical science by eliminating most of diseases from this earth, including fighting the global pandemic? And how mature is this research going so far?
And that is a fantastic question.
Yes, Namrata.
Yeah, so thank you. That is a really good question. Well, with regards to one, we'll split that question down firstly. With regards to how big data and neuroscience are interacting with each other, one of the most interesting things is, yes, we are still understanding how we can efficiently process a lot of information. And one of the biggest challenges with neuroscience data is the fact that a lot of this is not really super connected with each other. So very rarely are we able to connect all of the different elements together in one succinct fashion. So there are different analysis pipelines that are still currently being built out for us to be able to extract really great insights. With regards to diseases and being able to model different diseases, the labs that I've previously worked with have done a lot of work with regards to Alzheimer's research, where we have been modeling different disease characteristics, same with depression as well as even if you're looking at schizophrenia and Parkinson's, all of these various neurodegenerative disorders are currently being extensively researched and modeled. And large amounts of insights have come to the fore with regards to us being able to wrangle all of those different elements and pieces together to create almost different strategies that can be implemented. Now, one of the drawbacks or one of the limitations of working within this field is that it does take a lot of time, because you are dealing with data that comes from individuals and brain data, and the ethics behind that and the ethics committees behind that are extremely stringent with the way that data is being handled and with the way that that data is being processed. So for us to be able to create different strategies around that and different treatment plans also takes quite a bit of time. And as we've seen with the boom of the pandemic, yes, I'm sure everyone noticed how quickly vaccinations, for example, were developed for diseases such as the coronavirus. And the way that happened was because there was a really great strategy implemented from day one, with labs all around the world working towards one common goal, which was to be able to take society over this particular pandemic. Therefore, that is, if anything, that serves as a centerpiece for us to be able to utilize that same strategy with other diseases going forward. Really being able to collect data on such a large scale, interactions between different labs across the world, and really being able to support different research-based activities on a large scale for us to be able to really take that ahead.
Thank you so much. And I have a question here about urban planning. How can tree plantation help in urban cities' healthcare improvements, and how can NGOs contribute in this initiative?
Sorry, can you repeat, Dr. Aisha?
The question is, how can tree plantation help in urban cities' healthcare improvements, and how can NGOs contribute in this initiative?
Right. Well, the urban farming or plantation of trees for decorative purposes in urban areas, specifically in downtown urban areas, where we have dense populations that have barely any access to any public recreational spaces, not only enhances the well-being of those who are living in such spaces and giving them this biophilic feeling and being close to the nature and having access to it, but also improves the quality of that urban space in terms of air quality and improving life in general by balancing the environment in that urban space. So to a great extent, actually, plantation of trees, whether for decorative purposes or as urban farming, enhances sustainability. And we're seeing applications of smart technologies in that as well, in the sense that we recently just in Bahrain counted how many palm trees we have in the country, because we, for those who are not from the region, we have been famous for our palm trees in the past, and we've seen a lot of cutting of those palm trees. Like the rest of the world, we have deforestation, which is causing us tremendous environmental effects in the country. So technology can help in that, and in terms of measuring the amount of green towards hardscape that we have, so soft to hardscape, and then telling us or providing us with the necessary data to help us decide and make decisions on where to plant and where not to plant based on the models that we have. So NGOs, I think they could help in awareness to a great extent, because that's where we're lacking. We're not really aware of how much green impacts our lives, and I think that's the role of NGOs there.
Thank you so much, Dr. Faye. Dr. Ilham, you took us through the journey of deep learning and machine learning to artificial intelligence, and you compared between the traditional and the ML programming. You wrapped up your presentation saying that dark data is now a challenge to enhance the business performance. Can you shed a light on this point a little bit for me?
Yeah, that's a good question, Dr. Aisha. Exactly, as I mentioned at the end of my presentation, we're talking now. It's a trend, actually. We're talking about dark data, and dark data is, as I explained earlier, it's all about data that it is not used, and it is stocked on our databases. And of course, when you talk about buildings, when you talk about neuroscience and other fields, we always have data we keep on our databases, but we're not We do not actually use it. Perhaps we store it for legal reasons, or we store it because we have to, so and so on. I gave other examples such as log file, server log files. For instance, those files are used to detect the problems on your websites. So if we take this example, however, if we took those log files, they're there on our database, and we do not use them after that. If we solve the problem, from the computer science vision, if we solve the problem on your website, you do not have to reconsider using this log file. However, this is the dark data. You can use those log files to study the behavior of your website visitors. You can use them for marketing, for instance. You can have information of your customers, of your visitors, so you can have publicity which is only for some visitors and not others. This is one example from others. For instance, also in IoT, Internet of Things, as mentioned by Dr. Ahmed Khalifa. So we have so many information that are stocked on our databases, and we can, for instance, predict the consumption of energy in our house, how to optimize the electricity consumption, and so on. Those are really that's what we call dark data. This data is stocked, it's unclassified, it is unused, but we can take profit from it. We can take advantage of this data, and for so many areas, in so many fields. Thank you, Dr. Aisha, for the question.
Thank you, Dr. Ilham. And one question from the audience says, don't you think it's time to introduce AI in early stages of schooling to be able to teach them the new generations to understand AI and be able to deal and survive with it? What do you think of this question?
I think it's necessary to introduce AI techniques on our education systems. As a computer science professor, we still work in a traditional manner, I say. However, we can use AI techniques to improve our learning, to have better outcomes, to have students that are. It has so many advantages, of course, using artificial intelligence techniques. Of course, with this pandemic, the COVID-19 pandemic, we were as I said earlier, we had to survive. We had to use new technologies for education and for learning. This virtual summit is one example from among others. So it is a necessary, actually. It's a good question, and we have to, especially in the Arab world, we have to use those techniques so we can improve our learnings. It offers so much potential for us.
I totally agree with you, Dr. Ilham, especially that we come from academic background, and we see this really important at the coming generation. And I can see that the new generation is very much interested in data and very much interested in robotics and artificial intelligence. So at least we can feed them something beneficial from the beginning.
Exactly.
Right. Yes, I have some questions from the attendees, but I would like to go back to Victoria Khalifa when she was talking about the urban intelligence systems as a growing body of research. You shed a light on something really interesting, which is the city's digital twins. And you mentioned that Dublin included the citizens' ideas in their projects. Any other famous cities around the world have the same potential? And how do you see this cities' digital twins technology in the MENA region?
Well, we're seeing a lot of interest in cities in this, and there are various examples that could be looked up online: Singapore, London, Paris. Everyone is trying to create that digital twin to enable them to make better decision-making processes. Different countries are approaching things differently. As we saw, the Shanghai example was a bit different than what Dublin has done. But the whole idea, I think the core concept is to replicate the physical world so that you can try things out in the virtual world in an easier manner, because it's very hard to test things in the real world, but it's much easier to do it in the virtual world. So any mistakes that could happen, you could, they're just virtual mistakes that doesn't impact anyone. But mistakes that happen in the physical world have a lot of consequences. So the idea is to, try and test things out as much as possible in the virtual world, so that you can then implement them. Or if an incident happened in the real world, you would know how to deal with it in the best possible way. So it's bringing urban efficiency using urban intelligence by putting all of this information together and creating that digital twin. I think in the local region, Dubai is very much interested in this as well. In Bahrain, as I said, we have the imagery, or we have the tools required for the digital twin, but our project haven't been started yet. Hopefully one will start yet, now that we have the tools and the images and the sensors and the raw data that would enable us to create that digital twin. The capabilities are there. Creating the model, the 3D model, is not difficult. It's collecting the data that you would feed into that model is what is challenging. And I think we're going more towards that in the local context now.
I totally agree with you, Dr. Faye. Thank you so much. And mentioning the sensors, there is a question from the audience here saying that how far will sensors be implemented in our everyday lives from a political, ethical, or even scientific perspective?
If that question is for me from an urban scale, I think as much as we want it to, or as much as the regulation will allow, because sensors as a technology is there. I mean, it's used everywhere, but it's how much we want to use of it, really speaking. I mean, at an individual level, we now have the simplest versions of sensors in our homes and offices that tells us the clarity of the air, or things like that can be bought now online by anyone. And at an urban scale, this could be embedded in our lighting systems, in our traffic lights, in our CCTV cameras, and so on and so forth. So it is really up to each region and each individual to how much they want to use of that. So there's no limitation towards how much you can use in an urban space, if that's the question. But I do think that things should be regulated, because also the excessive use of those data collecting technologies without having the right governance for this and the right policies put place by the government is also going to cause problems. We've seen problems of drones in Bahrain before, and I think this continues to be a national issue. So yes, everyone can obtain the technology, but to what extent can they use it so that they don't harm other people is the question.
All right. Thank you so much, Victoria Khalifa. Another question from the audience is, does AI adoption impact or has an impact on competition, or does it give us a competitive edge? And before I listen to you, I would like to highlight on what Dr. Eva Marie said, because she's not present with us now in the Q&A. She said that AI will not replace managers, but managers that do not use AI will have a problem. And I really liked what she said. And this is an indication that AI, or organizations that adopt AI, would have a very robust competitive edge. I don't know if my fellow speakers agree with me.
Yes, completely. I think that anyone who does not get into this race will be soon outdated and will be replaced, I think, not by technology, but by people who understand those technologies. Because, as I said, sometimes, you know, we bite more than we can chew with this amount of information and data and technology that we have. And it's not an option now. It's a necessity, you know. There's digital literacy that is happening, and we need to, as we have overcome, you know, educational literacy, we have to work on that as well, because if you can't use it, you simply cannot cope. I'll just give a small example from the educational system. Being in the university and directing the e-learning, if you refuse to use the tools to enable you to teach online, you won't be able to teach online. Simply put, you know, in this in today, you know, where we are not able to teach on the campus. So it is not a matter of whether you want to. I mean, it's a necessity. So yes, they will be replaced by other people who want to learn and want to change the direction towards where they are. I mean, not everyone is a technology expert, but everyone will have to use the technology.
Absolutely, I 100% agree with you, and I believe we have a limited time to wrap up the Q&A session here today. The rest of the questions from the audience will be answered by the speakers and sent to you via email. Thank you very much for such a collaborative discussions here from the audience. Thank you so much. This indicates that you're so much interested in the topics that have been presented today. Allow me now to thank the speakers that are available: Dr. Ilham Sleiman, Dr. Sheikha bint Abdullah Khalifa, and Ms. Namrata Nagendra, and the rest of the speakers who were available earlier today. And now let us take you to the certificates presentations. Oh. Thank you so much for the organizers, for the presenters, for the attendees. Without you, this summit wouldn't have been successful today. And to close up the summit, I would leave the floor now to Dr. Jassim Haji. Thank you very much.
Thank you. Very useful session. Dr. Aisha, you thanked the speaker, so I don't have to repeat it, but somebody has to thank you. So I will thank you for the excellent moderation and managing the session, and clever questions, I would say. And honestly, as I said at the beginning of the conference, we've made 7 so far, I think, in the past 1 year. And this is one of the most interesting. And I got a lot of feedbacks personally on my mobile from the attendees, friends who were here. And of course, the subject is very potentially hot in the market, but I believe all of you made it more interesting today, and I would like to thank you again. I would like to thank a few people in the background, probably who were, you know, not known to the audience, have been doing a great job. First of all, the person behind all this is Tushar Sahu, who's always supporting technological roadmap in Bahrain, although he's sitting in UAE, and also his team, Ronit. He's been arranging all this for the past 10 days, day and night, and Vijay, Ajay, and all others who have been supporting us. Also, my friend here, Ahmed AlAwadhi, who's always supportive and works hard in the background, and he's been following up from the beginning till now. Of course, the big thank goes to Her Excellency and her team who supported us, and she's passionately interested in this, and she wants to take it forward with any suggestions and legislations that comes out of this conference, and they made sure to to note them down and send them, and of course they will work towards that goal. And Sheikh Afai, this was your idea when you called me a few months ago. I think we should take this further and don't stop here with this conference and let it die down, but more activities, whether it's through conferences or other disseminations. Thank you again to everyone. I will not take your time. It's been a long time, but useful one. So back to you for the last word, Dr. Aisha.
Thank you so much, Dr. Qasim, for the wrap up. I had the honor to be the moderator today in such a brilliant summit that discusses a very important topic, which is data. And I was also pleased to be there with such distinguished speakers here today. I can see that the attendees were really interested in the topics. Questions didn't stop here in the panel while the presenters were talking. And I thank all the organizers, and I thank you for inviting me to moderate this session and for the patronage of this summit. I'm looking forward for further events, and I wish you a wonderful day. Thank you so much.
Thank you all.
Thank you very much.
Thank you for having us. Thank you.
Thank you. Thank you for the opportunity.
Thank you.
Goodbye, everyone.